In this video, I am going to explain how to find the maximum number of positive roots, negative roots, non-real complex roots of a polynomial equation. So this is a polynomial. Before that, we have to see sign change, the concept of sign change. Then Descartes' rule. Descartes' rule will help us to find the maximum number of positive roots, negative roots, and non-real complex roots. So first let us see the concept of sign change. So in this polynomial, we can see here plus, then minus, plus, minus, next minus, plus, then minus, then plus. So here the term x square is not there. So corresponding to that, we are not putting any sign. Now here you can see plus is becoming minus. So at x raised to 6, there is a sign change. Now minus, again minus, so there is no sign change. But here x raised to 5, you can see before that minus, after that plus. So there is a sign change. Minus is becoming plus. Here again plus, again plus and plus. So there is no sign change. But here you can see plus is becoming minus, so plus is becoming minus. So again minus is becoming plus. So there are 4 sign changes. 1, 2, 3, 4. X raised to 6, there is a sign change. Because before that it is plus and after that it is minus. So x raised to 6, there is a sign change. That means at x raised to j, there is a sign change if the coefficient of x raised to j plus 1 is different from the coefficient of x raised to j. Here minus plus. So here 6, 7. So it is changing the sign at x raised to 6. Or you can say x raised to, it is changing the sign at x raised to j if a sign of the coefficient of x raised to j minus 1 is different from coefficient of x raised to j. So instead of this, you can say x raised to 7 sign is changing, because here plus minus. So here 7, 6. So it is changing at x raised to 7. Then x raised to 5. Instead of x raised to 4, we can say x raised to 5. The reason, here you can see minus, then plus. So either you can say x raised to 4, because here plus, minus, or you can say x raised to 5, here minus, there plus. So either x raised to j, x raised to j plus 1, or x raised to j minus 1, x raised to j. So here you can see either x raised to 6, 6 means plus minus. Here it is minus, then plus. So in that case also it is 4 sign changes, 1, 2, 3, 4. Then Descartes' rule. If P is the number of positive zeros and S is the number of sign changes, then S minus P is a non-negative even integer. Non-negative even integer. It is to be non-negative. That means it is to be positive. That means positive roots of a polynomial equation cannot be more than the sign change. S is the number of sign changes, P is the number of positive zeros. So the number of positive zeros cannot be more than the number of sign changes. If it is more than the number of sign changes, it will become negative. So it is non-negative. Then one more thing, it is even integer. S minus P is a non-negative even integer. Negative zeros of this polynomial p of x is same as the positive zeros of p of minus x. So for finding the number of negative zeros or negative roots of the polynomial equation, you find the number of sign changes in p of minus x. So p of minus x. So everywhere you change the sign and find the number of sign changes. Then s minus p, where s is the number of sign changes in p of minus x. Then p is the number of positive zeros in p of minus x. Then you will get the number of negative zeros in p of x. So s minus p, where s is the number of sign changes in p of minus x. Let us see one example. Here we have to find the bounds for the number of real roots. What is the maximum number of real roots? Let us use Descartes' rule. One polynomial is given. So x plus 1 into x minus 1, x minus 2 into x plus I into x minus I. From this it's clear its roots or zeros of this polynomial is minus 1, 1, 2. When you put 2, 2 minus 2, 0. So then minus I. So these are the zeros of this polynomial or roots of this polynomial equation. Polynomial equation, you have to equate it to 0, then polynomial will become polynomial equation. If you remove this bracket, then you will get the polynomial in the standard form. So this is x raised to 5, x into when we multiply x 5 times, so x raised to 5. So if you take the product, you will get this polynomial in the customary form. Now you see here sign changes plus minus. So at x raised to 4, one sign change is there. Again minus, minus, so there is no sign change. So minus is becoming plus here. So negative, positive. So here at x raised to 0, there is a sign change. So x raised to 4 and x raised to 0, there is a sign change. Here plus is becoming minus, here minus is becoming plus. So there are two sign changes. So here s is 2 sign change is there. Then p is the positive zeros of the polynomial. S minus p is non-negative even integer. So p cannot be more than s. So positive zeros cannot be more than 2. So maximum positive zeros of this polynomial is 2. Now to get the number of negative zeros, then p of this is p of minus x. Negative zeros of this polynomial is same as the positive zeros of this polynomial, where there is x, you substitute minus x, so odd power, so it's minus x square. When you put for this x minus x even power, so it will be positive, so this minus is there. Then for this x, when you put to minus x, so minus into minus, it's plus. Now you can see here there is only one sign change, minus minus, so now no sign change, minus is becoming plus, here plus plus, so only one sign change. So number of positive zeros of this polynomial cannot be more than 2. These are positive zeros of the polynomial, cannot be more than 2 as per Descartes' rule, cannot be more than 2. Negative zeros of this polynomial cannot be more than 1. So 2 plus 1, 3. So you can see 3 real roots. So number of positive zeros cannot be more than 2. See, only 2 positive zeros of the polynomial, or positive zeros of the polynomial equation. 2 cannot be more than 2. See, negative zeros of the polynomial or negative roots of this polynomial cannot be more than 1. So you can see only one negative zeros of the polynomial. Then minus I plus I, that is neither negative nor positive, so it's a complex, non-real complex roots. One more example. A polynomial is given, x plus 2 into x plus 3 into x plus I into x minus I. When we equate it to 0, it is polynomial equation. So zeros of the polynomial minus 2, minus 3, minus I. When you put for this x minus 2, it will become 0. So roots of this polynomial equation is minus 2. When you put here minus 3, it will be 0. So minus 3 is another root. Then minus I. Then take the product of this. You multiply x into x into x into x. So you will get x raised to 4. Then complete the multiplication. You will get the polynomial in the customary form. So you can see there is no sign change. Every term is positive. So there is no sign change. So the number of positive roots cannot be more than the number of sign changes. There is no sign change. So there will not be any positive roots. So you can see from this, there is no positive roots. Number of positive roots cannot be more than the number of sign changes. There is no sign change. So positive roots cannot be there. There cannot be positive roots. Now for getting the negative roots, you find out p of minus x. Wherever x is there, you put minus x. So when you put for this x minus x, since it is even power, it will be x raised to 4. Here odd power. So when you put for this x minus x cube is minus x cube. Then here it is even power. When you put for x minus x, sign will be same plus sign. Then for this x, if you put to minus x, it will become minus. So now there are sign changes. See, plus, minus. So one sign change, minus, plus. So second sign change, plus, minus. Third sign change, minus, plus. So 4 sign changes are there. So positive roots of this cannot be more than 4. That means negative roots of this cannot be more than 4. Negative. So Descartes' rule is giving the maximum number of negative roots or positive roots. So now negative roots of this cannot be more than 4. Now you can see there are only 2 negative roots. So Descartes' rule is giving the limit or bounds for the positive roots and negative roots. So negative roots cannot be more than 4. Here are only 2 roots are there. Now another example. So this is a polynomial x raised to n minus n c1 x raised to n minus 1 etc. Then finally minus 1 raised to n. So this is the expansion of x minus 1 all raised to n. In this expression there are n sign changes, plus, minus, minus, plus. So there are n sign changes. So the number of positive roots cannot be more than n. So this is a polynomial equation. So x minus 1 raised to n, there are n roots. So positive roots cannot be more than n. Then for getting the negative roots, you have to replace this x by minus x. So when you replace, there will not be any sign change. So the number of negative roots is 0. There cannot be negative roots for this polynomial.